Hello and welcome to the Introduction to Basic Concepts in Statistics. This presentation is for people booked onto my e-course, which you can find out more about at www.rosannagreen.com. It will take 12.5 minutes if you run through this presentation without stopping, but there are exercises to undertake, and I'd like you to email me the results to those pieces of work as you undertake them, and you'll want to just pause the presentation when you're doing them. But I would recommend that you work through this all in one go. So I look forward to hearing from you, and I hope you enjoy the course. The first basic statistical concept I'd like to introduce you to is the mean. The mean is a hypothetical value, and it can be calculated for any data set. It's hypothetical because it doesn't have to be a value that you actually observe in the data set. So for example, if we took 5 pub landlords and took a record really of the number of customers they get in on one Saturday night, we might find that at the first pub, we've got 100 customers coming in on that Saturday night. The second, we have 200. The third, we have 300, and so on. So the mean number of customers across the 5 pubs is 100 plus 200 plus 300 plus 300 plus 400. So all the data added together and divided by the number of instances of the data, which is 5. That gives you a result of 260 customers. The mean then is a statistical model created to summarise our data. So this is the first statistical model that you're being introduced to today. So now it's time to get creative. I'd like you to make up your own data set. What you'll do now is pause the presentation, make up your data set, calculate the mean value, and send me the data set and the calculation of the mean to my email address using exercise 1 in the header. Thank you. The second statistical concept to introduce you to is the median. This is another average score, but it's one that's observed in the middle of a data set. We calculate it by first of all ranking all of the scores in the data set and taking the one in the middle. So along the row that says scores here, you have the data set 2, 12, 12, 19 and so on. And we have placed those in ascending order and given the lowest score a 1, the second lowest a 2 and so on. Now in this data set we have 8 pieces of data, so the middle of this is somewhere between the 4th and the 5th rank, which means that 19.5 is the middle score in this example. The median is important to understand because SPSS uses this ranking process when you choose a non-parametric test. The mean is too sensitive to extreme scores, so if we had in this data set scores of 2, 12, 12, 19 and then 90, 90, 90, 100, the mean score would be much more reflective of around the 90 mark than it would of the actual middle of the data set. So it wouldn't be a good representation of the average of this data. The third statistical concept to introduce you to is the standard deviation. I'm abbreviating standard deviation to the capitals SD here, and it's a measure of how well the mean fits the data, and it's a measure of the average deviation of each of the scores in the data set from the mean. So for example, with our data from those pub landlords, we had a mean of 260. So the standard deviation tells us how much the individual data scores deviate from 260. So how far away is 100 from 260? How far away is 200 from 260? How far away is 300 from 260? And then it takes the average of those. So small standard deviations indicate that data points are close to the mean, and that is a good thing because we make a lot of assumptions in statistics and we need to understand how confident we can be about our data and the results that we're getting. When we have a large standard deviation in relation to the mean itself, that means that the data points are distant from the mean. So the mean is not necessarily an accurate representation of the data, and in our statistical calculations we therefore become more cautious about what we are assuming and what the results will be. So it increases our levels of caution really in doing statistics. So here is the equation for the standard deviation. The large letter that looks like a capital E means the total of everything that occurs afterwards. And after that you have in brackets xi, which is each individual piece of data, minus x with a line over the top, which is a symbol for the mean. And then we square everything in there and divide this total result by n minus 1, where n is the number of pieces of data in our data set. So going back to our pub landlord's customer data then, in the first pub we had 100 customers, and we take away from that 260, which is the mean, and square that before we then add the second piece of data, minus 260, and square that, and so on. And we then divide that by 5 minus 1, 5 being the number of pieces of data in this data set. So your task now is to calculate the standard deviation, and it's all been set out for you in the last slide, but it's a good exercise to do to ensure your understanding of the abbreviations used in describing the calculation of the standard deviation. When you've calculated the standard deviation, just send me the result to my email address using exercise 2 in the subject header, and also send me a sentence about what the result tells us about the mean. The normal distribution, or the bell curve, is very important in statistics, particularly where we're choosing whether to use a parametric test or a non-parametric test. We need to have data that is normally distributed to use a parametric test. So let's look at some real examples of data then. How long do cars last? This is a distribution of how long cars last. Some cars only last maybe 2, 3 or 4 years. Some of those really quick cars may last more like 12, 13 or 14 years. But the majority of cars will last somewhere around the 7 to 10 year mark. Now these lines in here indicate some parameters within which you might look at this data. Within the centre section here, nearly 70% of cars will last within this time frame of 5.5 to 10.5 years. There are far fewer cars that will conk out within 2 or 3 years, and of course far fewer cars that will last a much greater length of time. So we're now going to have a go at drawing a normal distribution. This is the same as a histogram, and you will need your graph paper for the next exercise. This exercise takes place in 2 parts. This is a data set for you. I'd like you first of all to calculate the mean and the median for this data set and send the result to me by email. On to the second part of this exercise then. I have repeated the data here on the left, which you've already calculated the mean and the median for. Now we're going to plot the data on a histogram using the graph paper that you have ready for this course. First of all, the data needs to be converted as shown towards the right of this slide. So what we have here is the frequency of the score 11. In the data set on the left, the number 11 occurs once, the number 12 occurs twice, the number 13 occurs 3 times, and so on. So this is the data that we need to be able to plot the data on a histogram. When you have completed this, if you have a smartphone, you can take a photograph of your result, of your graph paper, and email that to me at my email address. Thank you. Well, congratulations, you finished the first part of this course. Now that you've completed it, you'll receive a link to your email address to a demonstration of SPSS and a file attachment containing some data. So this is the fun part. We're going to start playing with data. You've got some great basics behind you.